Hi there, and a very warm welcome to this week's video in which we are going to explore deep images. So this is something BlackMagic implemented into their pipeline, so Fusion Studio and DaVinci. And Octane has the capability of exporting deep images for a longer time. So when it came in the beginning of the year, I thought this might be something for a tutorial, and this is today. So without further ado, let's grab your coffee. See, I have a new mug. Or do you prefer this one here? I don't know. Let's go and jump into this tutorial anyhow. Here we go. And welcome to Cinema 4D Land. If you're uninitiated and heard Deep Compositing for the first time, don't worry, this is an overview. So when I started preparing this tutorial, I ended up modeling this scaffolding here, and it took way too long because I needed to get all the parts in there, and I modeled all of it from scratch in Subdivision Surface. And the reason why I chose a scaffold is that it has a lot of depth layering, which is good to show off deep compositing. So let's follow me into Fusion Land to show you more. And welcome to Fusion Land. It has definitely been a while, so we are finally back and we see our rendered result here. If you know me, you're probably aware that I'm a huge advocate of rendering in EXR, so this is no difference here. Well, it's a little bit of a difference. If we zoom out here, this is actually a Deep EXR. Let me show you what this can do. So if we go to points mode, you can see together with your scene camera, you can get a really accurate representation of the objects in your scene. And this can be used to, for example, sandwich text in between of it and get the right depth and right occlusions from it. And it's actually much more precise and doesn't suffer from the artifacts that traditional set depth compositing was suffering from. Alright, now that you have a good overview over what it is, let's jump back to Cinema 4D and get started. And welcome back to Cinema 4D. I'm happy to announce that the settings you have to do inside of Octane and Cinema 4D are not that complicated. So basically it's just two check marks. One of them you can find in the Octane settings. If you don't know where those are, you can click on your live viewer on the cogwheel here, then scroll down in the settings and you can find the deep image here. Let's just turn it on. I will go over the options later. So this just enabled deep rendering. Now we have to take care about saving the image. So let's go to the outputs, go to Octane, and then in the main tab, go to deep image, flap it open. Then you can hit save and give it a path. Of course, render tokens are supported. There's even one exception where you don't need to tick the Save Deep Image file here, and this is if you go and output through your Render AOV manager, have set it to EXR and opt for a multi-layer file. Then Octane will save out a multi-layer file including your deep data. As I always go with single layer, I need to tick that in here. And believe it or not, this is all there is to it from Cinema 4D's side. The only addition I have to make is if you want your render passes also to be deep, you need to check this very explanatory tick here. So let's finally hit render, as I wanted to mention a couple of more things in the picture viewer. Once the scene is loaded, you will see that it will begin to render and there's nothing out of the ordinary here, but you can see that the progress bar is stuck for a couple of seconds and then it will jump forward quite a bit. And this is because it will gather all the samples that are necessary for the deep image. This also comes with a render overhead. It's not too steep, but you should be aware of it. Also, another thing that is important to know, as the images that we are just rendering are pouring into our folder, you can see the deep image is much larger than the other images. Of course, it has to hold a lot more data inside of it to produce all of this deep information. And therefore you have to expect a bigger file size. And we are already back in Fusion, so let's make a new composition and see how this all turns out. In the composition, let's just use one view and then drag in one of the images of the image sequence and see if it loaded correctly. It seems like it. Of course, let's make sure that everything worked out and we are working with a deep image all right. So what we can do is, of course, what we did before, zoom out and have a look at the top right corner. But what we also can do is in the attributes of the loader, go to Format, and here you can see it's tagged Deep Image. As an option here, if you don't need the deep data, you can scrap it by going to Flat Image, so the image will be loaded as float 32-bit, as a normal image basically. If you decided to go on this wasteful path, then Fusion at least gives you a small present in the form of a set depth, because it already has the full volume information, and this is the least it can do. But we are not interested at all, we want to go deep. It's worth mentioning that as soon as we engage in a deep workflow, color processing nodes such as the color correction won't work anymore. This is because it has its own sets of tools. I won't go over all of them today, but if you're interested where to find them, then go to Effects, flap that open, and then you can see Deep Image. Here you go. Let's start building. One of the first cool things you can do is go with a point cloud from your image, and this is of course deep to points. So if we drag it out and connect it, then select it, you're suddenly in the 3D space of Fusion. If you're used to the old navigation for Houdini, Cinema 4D or Maya, then this next thing will be a bit tricky since this is not the old navigation at all. If you hold down Alt and the middle mouse button, then you can rotate. If you hold down Control and scroll, then you can zoom. And if you just hold down the middle mouse button, you can translate. And of course, as you can see, we already have a point cloud here, but if we tilt to the side, you can see it's very squished and thin. Of course, if you have keen eyes, you have already spotted the depth scale here. So if we set it to a whopping 1 and then translate over here, you can see it looks a bit better now. Now, if I zoom out just a tad bit and move the playhead, you can see that this is still wonky as fuck. Sorry. The reason is that one essential thing is missing to tie it all together that you probably have seen in the beginning, which is the camera. So let's go over to Cinema 4D and export the camera from there for Fusion. And a very enthusiastic welcome back to Cinema 4D land. Your enthusiasm though might be a little bit dampened if you figure out that exporting the camera is not a one-click solution but a multi-step process, but I'm here to guide you, and if you know what you're doing, it's not too bad at all. Also, disclaimer, I might be overlooking something, so if you know a better way to do that, basically a one-click solution, then just shout out in the comments down below. Now, we have two things to tackle when it comes to the Cinema 4D camera export. One thing is size, because Fusion needs a very certain size in order to work together with the Deep Image point cloud. And the other thing is basically very essential, and this is the keyframes. They need to be right. So in Cinema 4D, I usually use a camera rig, and calling it a rig might be a huge overstatement because it's just a null with a housed camera. Believe it or not, this almost non-existent setup creates a lot of problems when exporting the camera, or trying to do. So my first action is to copy everything into a new scene, like this. Let me zoom out here to show you my camera rig, of course in big quotation marks, so we have a null object that is rotating as well as some other animations on the camera to make for an engaging camera move like this. Believe it or not, but the inverse matrix of the setup is enough to break our export. So what we need to do is to bake our camera into keyframes before we export ourselves. It's a very fast setup that can be helpful in a whole lot of situations. So first of all, let's duplicate the camera. Then what we need to do is go to the programming tags and get an Espresso tag. In here, we load the old camera as well as the new one and select both with global matrix and then just connect that. Here we go. And that's basically our setup done. What we've done here is make our new camera follow the exact path and orientation of our rigged camera, but without the rig, which is very helpful for baking into keyframes. So let's do this next by conjuring up the timeline. Our camera is already selected. Don't worry that it has keyframes, they are overwritten by the tag. So what we need to do is go to Functions, then go Bake Options, and then Bake basically. We don't need to create a copy since we've done that ourselves. Let's just bake into keyframes. Here we go. That was fast. Before exporting, let's go to the Espresso tag one more time and disable it so it really uses the new keyframes. Then we can actually start exporting by going with either FBX or Alembic. First I thought Alembic would be the better option because it's more modern, but I fell on my nose as nothing was working, so we are going with FBX and I have to record this twice now. Don't ask me why, but in contrast to Alembic, FBX does not have a scene export scale. So the best way I found is to copy our camera into a new scene and before we paste it in, set the scene scale here. Probably my scene defaults vary from yours because I use millimeters. I know that it's usually centimeters, but I work with very small scenes and so millimeters is more accommodating. Therefore, your results might vary and you might need a couple of exports to get it right. So for me, I noticed that if I export in meters, then I get the right scale. So let's paste in the camera there and you can see it's very close to the scene origin. Last but not least, let's finally export by hitting File, then go to Export and search for FBX and hit the cogwheel, make sure the camera is selected, click OK, and basically call it the same as our Cinema 4D file. Click Save and then see you in Fusion. I might prompt you to use the rabbit emoticon one more time this time, although we just lately used that, because we are hopping back and forth between software packages like bunnies. But let's not forget our manners. Welcome to Fusion Land. I tried to drag in the FBX file, but without any good result, so what we need to do is go to the files and then import and choose the FBX from here. Make sure the scale is 1. The FPS here is matching and then click OK. This brings in two cameras. Actually, since we didn't look through the camera while exporting, this also exports the scene camera, which actually is never visible in Cinema 4D. Kind of funny. Let's delete everything we don't need so we finally end up with our camera. And then what we can do is plug that into the green knob here and see the magic happen. Here we go. So now, if we did everything right, let's center this a little bit better, then move our camera, and we should see that everything stays put. Of course, the things outside of our frustum are gone because pixels are only living inside of the picture frame. But as you can see, everything stays put, rock solid. Very nice. By the way, this rock solidness was not the case with our Alembic camera, so hence the re-recording. Let's make this happen and bring in the 3D text that you've seen in the intro, finally. To do so, let's hit Ctrl Space and type in text, then double click on the text 3D tool here. What I want to do is merge it with the rest. To do so, we need to drag out the line and drag it on the deep points output, and this will create a merge 3D. Make the merge 3D active by dragging it into the view. Then we still don't see any text here, and this is because the text field is empty. So what we can do is deep enter image. And if we move a little bit closer here, you can see it's already set in there. Kind of. To better see what we are doing, let's actually go for a final composited frame. So what we need to do is make merge 3D active, then again hold down Ctrl and Space and get render 3D. So render 3D is basically rendering out our text now. If we employ the same trick as before and scroll out, we can see we're barely rendering a float 16 image and not a deep image, but keen-eyed among you might have spotted that there is this option for a deep image here. So if we click that, seemingly nothing has happened, but we changed the output. And now it matches the output from our input, so from our render file, which actually lets us merge those both. So what we can do is do the same trick here, go with output to output, and this creates a deep merge. So if we output that, you can see that it finally does the right thing, as it will display the text in the right depth and also does intersections. Very nice. To make things fast, I will pretend that you have two questions right now that I have the answers to. First of all, why the heck is everything so dark all the time? And second, how does all of this actually work? Great that you're asked. I have the answers right away. Let's talk about the darkness first. This comes from the linearity of our EXR files. Those are stored linearly for better compositing results, but this has to be countered later on, so we get the right brightness back. If you just rendered linear sRGB, it's very simple. We can go to the LUT section, click on this arrow here, leave it at Fusion View LUT, go to Edit, and change the gamma here to 2.2. If you want a one-click solution though, not that this was very hard to set up here, then Reactor has you covered. This is Fusion's plugin repository. If you open Reactor and look for sRGB or Rec 709, you will find plugins that let you just click once, like this. You might have seen that the dark tones changed ever so slightly. This is the small difference between a Gamma 2.2 and sRGB. If you have a photographic memory, you remember that I did go with ACES CG instead of linear sRGB, but there's also a solution for this. Of course, the solution involves our LUTs again, so let's go with OpenColor.io display. Go with the Edit button here again. What you need to do is load the ACES OpenColor.io here. Make sure the ACES CG and sRGB is matching. Somehow we need to toggle it. So there's a small bug here. Here we go. And now you can see it's darker, but it's there. Before we talk about the technique that makes all of this possible, let's finally move our text here in place. To do so, let's display the whole image actually by going to Scale and Scale to Fit. You can also see that the Render 3D seems to be the wrong resolution here. So let's check this. Yes, it's UHD, but we only need full HD here. What I want to do is move back to our 3D view and then rotate the image, zoom in a little bit so we can see better what we are doing. Go to our text and make some adjustments. For example, I want to left align it, then move it a little bit more to the right. And also what I want is to get the gap a little bit smaller here. So in the line spacing, go with 0.65. Here we go. If you want to have those gizmos active while looking at the perspective that you will later see in rendering, so if we do that, then the gizmos are gone, there's another trick. You can look through the camera in 3D space. So if you right click, then go to Camera and then Camera, you see what you see in the final render, but in 3D space basically. If you're thinking what I'm thinking, no, it's not about world domination, it's about the coarseness of the points. So I want to have a higher point count here, and this is possible by going to the Deep to Points and upping the density. Right now only 10% of all points are showing, so if we go to 100%, this gives us a much better view. Though the best way to judge is of course the final rendering, so what you can do with this is go to the transform of our text of course, and then move it from there. So for example, if I move the set, you can see the whole thing at its play and the magic that is happening here. Very nice. Before we do the finale, let's actually do the thing and answer your second question. What thing? Well, chart time. A very warm welcome to a small session of chart time. Oh, chart time, how I have missed you. To understand how a deep image works, let's first look at a normal image. So a normal image is made out of a pixel grid. In this case, it's a very small pixel grid. And if it's a colored image, then one of those pixels has 3 channels, red, green, and blue. Some of the images have the ability to store extra channels, such as alpha, for example, for transparency, but also set depth for depth information. While this extra data is very appreciated and can definitely be put to good use, especially in dynamic 3D scenes, the set depth is very limiting because it can only store one depth value per pixel. So whenever you have varying depth in your pixels, for example on the edges of objects where you have anti-aliasing, there is mixed in color from the foreground, from the object itself and the background. And without a saying, this also goes for transparent objects or partly transparent objects such as our cloth in our scene that we just worked in. So the trick here, while ray tracing the scene, is to not just ask for the pixel color back, but also for the depth of the information. So what we can do is add deep data where we have multiple samples per pixel. So we have a second layer of RGB, a second layer of alpha, a second layer of set depth, and this can continue for multiple layers. So I guess this also answers why the deep images can get so big, because they have to hold multitudes of the data that one single flat image can hold. How big they get also depends on the 3D scene and some render settings to output them. So let's have a look at Cinema 4D one more time. And welcome back to Cinema 4D land. Now, once you know how all of this is working, I guess those settings are not a mystery anymore. To state the obvious, max depth samples is the amount of layers each pixel can hold. You can basically see how large a EXR gets if you have a grassy ground and turn this up to 32. Depth tolerance, on the other hand, is a measure against wasting depth samples. If a ray hits something and creates a depth sample and then continues on its trajectory, it cannot produce any new depth samples within this distance. Since everything is measured in meters in Octane, this here is 5 centimeters. Welcome back to Fusion Land and our finale. Now, something that I want to do is get the background to be black. We can probably do that later on in 2D land, but why not do it in 3D and show one more thing? What I want to do is get a black background, so type in BG. This is a 2D background, but we don't care. Let's go to image and make it smaller, full HD. Here we go. Right now, there's no sensible way to add this to our deep image stack here, but there are tools for this. So if we flap this open, go to deep image, there is image to deep. Here we go. This lets us place 2D images in our deep composite. So if we add it, we only see black, and this is because right now our plane is right in front of the camera. To actually get it to be a background, what we can do is move the set offset. So if we move it slowly, you can see more and more of the depth appearing in our scene. And if we move it further away, so nothing of our scene can ever touch it, we have a black background. Easy as that. And if you did everything that you needed to do within your deep compositing pipeline, and by the way, we only scratched the surface, you can, for example, merge two 3D scenes together or merge a 3D scene with a volume. There's one more thing to do to get to the world of the image processing nodes, and this is the deep to image. And of course, it goes last before we can then add some more processing. I just copied the following from my standard comp setup. So if we connect that, we can make it look a little bit nicer like this. I did a Fusion video where I go over my non-deep process. You can find it in the upper right corner right now. And that's it. Hopefully you liked it and it gave you some insights into formerly unknown territories. Hopefully I managed to keep you awake. I know time is a relative concept, but looking at my watch, it's almost 5 o'clock AM in the morning and I recorded through the night here, so my judgment is slightly clouded. Anyway, thank you for staying with me till the end. Let's thank those people who made it possible. Obviously, my Patreons. Especially my €50 tier subscribers, Shields Augustinen and Leon Studio TV. Also, of course, a huge thank you for my €15 tier subscribers, for Die Thieves, Alessio De Vecchi, Ami Schiedried, Christian Grajewski, Graham Bucknell, Grigoris Morikis, Ivan Tanasiewicz, Joel Mackimer, John Edward, Chris Clemson, Lucas M. Silveira, Mike Rogers, Mikkel Obenhuis, Ness Graphics, Nico Straub, Part 1 of 2, Ralf, Random Capybara, Raiko, Shiro 2049, Zoo Shag, Terry Wayne Ranson, Jan Verbeeke, Yasin Rupp, and Yuri Starikov. Hi there, and welcome back to the backstage area. That one was an interesting one. A lot of preparation has gone into it. I spent so much time setting up the scene, and I don't think it's really showing. The good thing is that you can download the scene via my Patreon and therefore get access to it, and if you need a scaffolding, then you have it. Also, I might introduce new parts to it because right now it doesn't have any boards to stand on, for example, or any stairs. Fingers crossed I have the time and motivation to update it sometime. I think you can get some really nice renders out of it though. I almost have the feeling that in the 3D community it's a thing to do a scaffolding render from time to time. I don't know. Anyway, I just noticed that I haven't prepared any emoticon to go with. So let me just hit pause and search one. After 2 minutes of research, I'm back. Let's go with a puzzle piece emoticon because everything fits together so well with the deep images. Now, thank you for watching this, or more listening to this famous last word part. I wish you a fantastic start into the week, and if you're watching this later, a fantastic time ahead. And I say happy depth sampling, but watch your hard drives. They might be overflowing in an instant. Bye.